Hello all, in this video we are going to do some hands-on with R. So first we are going to go to internet and go to Google and we are going to choose this football data set. I think I have it. England football data set. Yeah, this is the football data set and of English Premier League, and then here is the English Premier, all years of English Premier League data set from I think 1994. You have English Premier League data sets for each year's Premier League's data sets you will get. So we are going to work with you can have lower division data sets also there, championships, League 1, League 2, conference. So all these data sets are available from the English football league. So I'm going to start my R, going to start a R script, and if I go there and maybe I'll just take 2122. So copy the link address and I will just say read.csv, give the path header equals to true and run this, and the data just downloaded. It just downloaded the data from the internet and it has 380 observations with 106 variables. So there's observation about 380 matches. Okay, there are observations about 380 matches. Okay, and then their divisions and everything is there. Now it's about home team and away team. FTAG stands for how many goals were scored by the home team, how many goals were scored. FTAG stands for how many goals were scored by the away team. Then there are other observations, and then there are different betting ratios by different betting houses, and lot of other things are available. And if you want to know each of those variables, so here is a note they have provided. So FTAG and HG is full-time home team goal, FTR and result is full-time result. H means home team has won, D means draw, A means away team. Then HST means home team, how many shots on target. AST away teams, how many shots are on target. HHW means home team hit woodwork, home team shots, away team shots, all these things, how many offsides, yellow card, red cards, home team booking points, 10 for yellow cards, 25 for red cards. So all these things are already there, and then in addition there are some other values are there, like odds. Different odds are also there, winning odds, and all these odds are there. Many betting houses gives odds before the team wins or not, before the team match starts, and these odds sometimes may have some predictive power for home team. So I will do some analysis. Okay, so let us see data So maybe I will just say FTAG. This one I will do table. So how many goals are scored by, so this is FTAG, how number of goals scored by the home team is essentially, see, it's a count variable, right? So if you just do a table, okay, then there are, out of 380 matches, there are 93 matches where home team did not score single goal. There are 121 matches where home team scored one goal. There are 89 matches where home team scored two goals. There are 50 matches that home team scored three goals. So like this, you can do a bar plot of this. We can do a bar plot. Okay, so this is a nice bar plot. Okay, and then you can do similarly, instead of home team you can do a away team. Okay, and we can do a bar plot, and you can see the away team's distribution is slightly different. Away team's distributions is slightly different. So away teams cannot score any goal in 119 matches. 123 matches they score exactly one goal. There are 75 matches where they score 89 goal. 38 matches they score 3 goals. So it's looks like in away teams score less number of goals in on an average they score less number of goals in away matches, a team. So we can take mean of the home team score. Okay, so 1.51, and we can take the mean of the home team score on an average 1.5 many goals, whereas away team score looks like maybe less, little 1.3. So this is a typical basic summary. Now we want to, if you want to model, we want to model the number of goals. We want to model, we want to model number of goals. Okay, so how do you want to model number of goals? So goals by, say, home team, suppose. Okay, as function of odds ratio, say bet 365 odd ratio. Say there was some, okay, if you go out, or maybe HS stands for short, or HST. I think if you go there, HS or HST, HS is the home team shots and home team shots on target. So we will as a function of HS, HST, home team shot on the target, and home team corners, HC. Okay, and home team fouls committed, HF. These are the functions I can, and home team offside, HO. So these are the functions, these are the thing, and home team yellow card and home team red card. Okay, so if it says as a function of home team yellow card and home team red card, so we want to model FTAG. So definitely we want to model FTAG as a function of all these variable: home team shots, home team shots on target, home team how many corners they get, HF is home team how many fouls they committed, how many offsides they did, home team how many yellow card they found, and how many red card they saw. Okay, so what I'm going to do, I'm going to say split the data. Let's split the data into train and test. Okay, so train ID will be, say, sample. Okay, I need to, before sampling, I need to set up a seed dot seed SM1124, right? Or I will just do a sampling instead of some 1:2000 comma 138. Okay, I'll take this number as my seed. If you use the same seed, you will get the exact same result that I'm getting. So 1:2, okay, 1:2 n row of data. So n row of data is 380, and I think what I'm going to do is n row of data, and m is ceiling of m times 0.7. so m is, okay, first I have to, sorry about that, m is 266. So what I'm going to do is n comma m replace equal to false. I don't want to replace. All right, now let me run this. Okay, sort, I would like to sort it. So one time sort, so it's not a problem, and it's a small data, to be honest. And then I have df train equal to data train ID comma and df test equal to data minus train ID comma. Let me have a run. So these are the data set that we got. This is the training data set, and this is the test data set that I got. All right, nice. Now what I'm going to do, I'm going to fit a Poisson regression model, fit a Poisson regression model. Okay, so let me try model 1 as GLM. I'm going to call GLM, and then obviously this model that we are talking about with the data equal to def train comma family equal to Poisson link equal to log log. Let me try this. Okay, it's saying not found. Okay, so let me see. There is a, I think there is a HO HR. Okay, so though they are saying they have an offside, but I don't think they have provided the HO value, the offside. So okay, we will see. So let me, actually what I can do, I can just HO home team offsides, but I can't see this home team offside value is actually available. So let me just run this. Yes, now it is being run. So what I can do, in fact, I can just write down this name of this variable. HS is home team shots, and then HST. Stands for home team shots on target, home team's shots on target, and then home team corners. HC is home team corners. Okay, and then HF is home team's foul committed. How many HF is how many fouls committed, and away teams, oh no, sorry, HY is home team's yellow card. HY is home team's yellow card, and HR is home team's red cards. All right, so we have done that. And summary, let us run the summary. And so let us see how it is. So HST, it says HST has a significant effect on the number of goals that you scored, obviously. And then they are saying that home team number of yellow cards that you have seen has a negative impact. Rate doesn't have any effect. Okay, probably it will be 0 in it anyway. So this is an interesting thing. But the other things like HS, how many shots you are taking doesn't going to help you out, but how many shots on target, that is going to be extremely important to number of goals scored by the home team. Okay, so what we can do, we can also put a step function here. And if you do that, the simple model will be built by HST and HY. Rest of the variables are being kind of dropped off. Now I can build the same model, similar models with the away team's goals also. So that will be a second model, right? Maybe I will just, along with these variables, but we'll only modeling the home team's goals only. Away team, how many shots they have taken. Away teams, how many shot on time, target, on their target. Away teams, C, F, fouls committed. I think what was the HC is home team's corner. AY and AR. All right. Now if you do run stepwise selection and ask your model 2 to run, okay, how many shots on target has a positive effect and how many shots on target by the away team has obviously a negative effect, but still it says a very strong effect. So it might even happen that it has some kind of quadratic or some kind of non-linear effect. So in case it has some, we would like to have it square, maybe cube, we don't know, and then maybe I into AST, square effect, and IAST cubic effect. And let me just run this with, and then if we just run it, this is interesting. This HST T with even has a square and quadratic effect as well. So this is really interesting that I'm getting. I would even not mind to put few more engineering effect. Just t to the power 4 I hs t to the power 5. Okay, this is ast, this is ast. Now if I run it, and if I just see this, okay, fifth power does not have any effect, but up to fourth power home team shots on target has a very significant effect. So this is a very interesting phenomena that we just found. In fact, you can try few more engineering things, but I'm just stopping here for now. And what I want to predict the number of goals scored by the home team, and number of goals scored by the home team, say predict 1 from the model 1. We would like to predict from the model 1 and new data equal to df test and type equal to, you have to say, response. So this is predict, these are the predicted values. And now what I have to just do, I want to just plot the from the df test dollar home team score actual, the test data set, how many goals scored by the full-time home teams goal, FTAG, and the predicted values. If I just plot them, 20. So we see that, so on the x-axis this is the actual number of goals, whereas these are the predicted number of goals. So there is some kind of, you can do predict to an extent, not great, but you can do that. So I can compute r square approximately by just taking the correlation between the two and then square them up. Call, yeah. So you can see this is not very strong r square, but let us try the other model. So predict 2 model 2, and if we predict the second model is slightly maybe better in terms of its prediction on the higher cases, and then it is it's actually against the 2, so now it is about 4-point increase that we are seeing in the second cases. Now if we consider this second model as sort of a best model, then we want to see if any of these betting odds has any predictive power or not. So what I'm going to do, I'm going to develop a third model, mod 3, which is essentially update the model 2, where I will do just add a few more variable. So I will just go and say B365 Will I be B365H? If I do that, can I get a better model? So summary, so fit the model. I'm saying basically in the update is a built-in function in R. You can fit the same model, whatever the second model you have here. Along with that, you take another predictor B365H on the same data set and everything. Now if you fit a summary with say mod 3, and is B365H has a predictive power? Is it a significant? Looks like it does have a significant effect on the number of goals it scores. So what it does is then can we predict from this? And let us do that and take the second model and do the third prediction. And if we do that, and then what is the plot? How does it improve significantly in the out of the sample? So maybe a little, we don't know. Let us compute the correlations. So it is 3-1, almost same. Oh, sorry, I have forgot to update the third prediction here. So a little bit. So what we can do, we can just take the first 3 prediction in a vector, and this is the predict 1, this is predict 2, and this is predict 3, and we can just so this is the first model, 27%, approximately 27% accuracy that we are seeing. This is the second model, the 31.7, and the third model with Bet365, we are getting 31.8% predictive accuracy. In terms of, these models it's not very great, but at the same time, this shows that sometimes your predictive model, it has some predictive power which you cannot ignore, but at the same time, it's not great. So there are a lot of rooms to improve. I would recommend, why don't you try yourself? That I will share this code on the NPTEL platform, but at the same time, I will highly encourage you that you should try this, try yourself, and and tell me what is your predictive out of the sample predictive accuracy. This is my out of the sample predictive accuracy. Not good, very bad actually. I would not say actually very bad, because these are very difficult problem, and it's a predictive accuracy in the out of the sample you cannot ignore. It's not like 0 or 5% or 10%. It's like 30%, 32%. Not bad, but you can improve a lot. There is a lot of room to improve. So why don't you try yourself? There are lots of variables. I think 100 plus variables are there. Try yourself, and maybe you can push it to 60, 70 or 80%. Why not? So try yourself, and so we will and write me in the YouTube videos link, or you just email me, and what is your accuracy you got in out of the sample, and what model works for you the best. Thank you very much. See you in the next video, next lecture.